Generators. In this video, we are going to look at AC and DC generators. In a generator, mechanical energy is converted to electrical energy, so motion in, electricity out. In grade 11, you learnt that a changing magnetic field induces an EMF and thus a current in a conductor. When a conductor is moved in a magnetic field, a current is induced in that conductor. Without complicating things too much, the charges inside the conductor are moved by the motor effect when they are themselves moved inside the conductor. Faraday's law of electromagnetic induction is the process in which electromotive force, or EMF, is induced in a closed circuit and is due to changes in the magnetic field around the circuit. Lenz's law states that the direction of the induced EMF, and hence the induced current in a closed circuit, is always such as to oppose the change in magnetic flux producing it. These aren't the full definitions, but it's worth remembering the principles that help us make electricity. We can use the movement of a bicycle to make electricity by moving the magnet inside the coil, changing the field and making EMF in the coils around the magnets. From this, we can conclude that EMF is induced whenever the magnetic field lines are cut by the coil. To be more precise, the more accurate terminology will be the change of magnetic flux in the coil induces an EMF in the coil. Mechanical energy from the movement of the magnet is converted into electrical energy, green energy from a substantial source, our legs. So, for generators where mechanical energy is converted into electrical energy, we use Fleming's right-hand rule to decide in which direction the generator will turn or in which direction the current will flow through the coils. It's exactly the same as the left-hand rule, but we must use the right hand. The first three fingers on the right hand are at 90 degrees to each other. The thumb points in the direction of the thrust, the first finger in the direction of the magnetic field, and the second finger in the direction of the conventional current. The letters help us remember uses of fingers. Generators work on the same principles as motors. The parts are the same with the exception that there is no electrical power supply. Instead, there is some form of turning mechanism. In fact, you can turn an electrical motor into a generator simply by turning it yourself. The electricity then flows out. Let us look at a DC generator. This is the principle on which a dynamo works. A simple DC generator has only one turn of wire. This coil of wire is called the armature. The split ring commutator serves as a change switch, which reverses the current after every half revolution. The commutator is made from two round pieces of copper held apart and do not touch each other, one on each side of the armature. So the brushes made of carbon only touch a wire that is moving in a single direction. That way the current only flows in one direction. So direct current. But the current isn't made consistently. Sometimes the change in magnetic flux during the turn, sometimes it isn't. Let's freeze things for a moment. A typical question asks us this. Use the diagram to explain what is happening in the graph. The frequency of the armature is 50 Hz. First, we see that there is a split ring commutator which tells us that the current flows in one direction only, a DC generator. This means that the graph lies above the time axis and only positive EMF is made, but it's lumpy. Why? Because in the first position A, the magnetic field and the movement of the wires are parallel to each other, making no EMF. The same reasoning would be for the last point E as well as the middle point C. At each peak, the magnetic field and electric field are perpendicular to each other. This is a maximum value of the EMF induced. Let us now look at an AC generator when the current changes direction. An AC generator is driven by something like a handle or a wind turbine that moves the coils of the armature relative to the magnetic field. The only difference between a DC motor and an AC generator is that the DC generator has a split ring commutator, whereas an AC motor has slip rings. The slip rings are connected to the external circuit via brushes. The direction of the current changes with every half turn of the coil, as one of the loop sides moves to the other pole of the magnetic field. The current in the loop changes direction. The attachment of the slip rings to the armature can be seen in the diagram. As the current direction changes with every half turn, the graph would be seen as a sine graph. The direction change is shown by the graph going below the time axis. The diagram shows the position of the armature as it turns. If the magnetic field and the current are parallel to each other and no EMF is produced, this is shown by position 0, 180 and 360 again. Therefore, the graph passes through 0. At 90 and 360, the magnetic field and the current are perpendicular to each other, and a maximum EMF is induced. The armature is connected to slip rings as the graph produced is a sine wave which indicates direction is changing periodically. To recap, both motors and generators can be explained in terms of a coil that moves relative to in a magnetic field. In a motor, a current-carrying coil magnetic field experiences a force on both sides of a coil, creating a twisting force called a torque, which makes it turn. In a generator, the coil is attached to an external circuit. The generator is turned, resulting in a changing flux that induces an EMF. The uses of AC generator is to generate electricity at power stations, to supply electricity of equipment at construction sites, to supply electricity to fun fairs. A bicycle dynamo uses DC generators. Factories that do electroplating require a huge amount of direct current. In older vehicles, DC generators are used to charge batteries to supply the vehicle with electricity. Can you think of any other use of generators? Rail generators have many coils on the armature, so there is always a coil moving perpendicular to the field. The magnetic field in rail generators is supplied by electromagnets. In South Africa, all of the power stations use AC generators. steam turbines are used at the power station to provide the mechanical energy needed to drive the generators. About 90% of our power stations are steam-driven. The steam is produced from the heat generated by burning coal. Coburg is our only nuclear power plant so far. Nuclear fission releases heat, which turns water to steam to turn the turbines. And the Lesotho Highlands has a hydroelectric power plant which uses water to turn the turbines. AC generators are used as backup power sources. The generators usually use diesel for the engine, which provides the torque for the coil. Motor cars have generators in them to charge the battery. The torque is provided by the turning car engine. Older model cars have a DC generator. Modern cars have the AC generators called alternators, and the current is converted to DC using a rectifier. That is a set of diodes that only allows for current to flow in one direction.